Hi, good day. I'm Brian Patrick Balin and this is my classmate.
I'm Matthias Lawrence Lim.
And we are here in Mechanical Engineering Department at Don Bosco Technical College in Monterrey City. And we are here to discuss to you the heat transfer modules and different kinds of sensors that can be found on it. First, we are here to discuss to you the newly installed flow meter. And here is Matthias to give you an idea what is a flow meter is.
First of all, what is a flow sensor? A flow sensor is a device for sensing the rate of fluid flow. Typically, a flow sensor is the sensing element used in flow meter to record the flow of fluids. It is consist of plastic valve body, a water rotor inside, and a Hall effect sensor. It's also inside. When the water flows through the rotor, rotor rolls. Its speed changes with different rate of flow. The Hall effect sensor outputs the corresponding pulse signal. The pulse signal is in digital signal. This one is suitable for our project. That's why we use the sensor.
So I'm here to explain to you how does the water goes through the flow sensor. First, the water comes from this green tank. It stores all the water. When you turn on the pump carries the water up to this pipe and goes to the flow meter right here. And the flow meter then calculates the number of pulses, the number of pulses of water that goes through.
You may ask, what are pulses? Pulses are the number of cycles in the rotor of the flow sensor based on the amount of the water that goes through it.
So there are two kinds of flow. First, the cross flow, and second, the parallel flow. First, the cross flow. The cross flow goes through here to this pipe and enters the module on the opposite side and goes to here and exits up, back, and down and enters our sensor here. And the second flow is the parallel flow. The parallel flow is the opposite of the cross flow. The water enters here and exits on the other side. So here is Tristan Realina to discuss to you the codes used in the flow sensor.
Good day. As my comrade said earlier, the pulses are used by the program so that it can be calibrated for us to get that flow per hour. Now, based on our experiment that we did earlier in the last video, we showed here that the pulses flow calibration factor is exactly 4.48, in which we use that 4.48 in our program so that our liters per hour can be accurate. So here we're going to test our flow sensor now by showing you in this program. So this, can you turn on the module, the transfer module? So you can see here there are 0 liters per hour that flows through since the module is still closed. But after some time, once we open it, you can see a sudden change. It went from 0 to 26 liters per hour to 1,366 liters per hour and rising. And now it fixes itself to up to only 435 to 466. And now we're going to use this data so that we can get the average flow of the system. So this is the calibration that we did for the flow meter. We calibrated it so that every pulse that we did in the trials are recorded and each time it's per minute, and we average it to get our calibration factor.
Good day, I'm Jake Olanes and I'll explain how the DS18B20 temperature sensor works. In our project, the heat transfer module temperature sensor, it is placed here and here. For this video, we will only show you the temperature sensor at the first point, which is here, that's the starting point. DS18B20 works by the program that Dallas gave it, and by the Dallas that made the program. In this computer, it is showing you that the temperature that is measuring now is 33.38 or around 33.44. The DS80 works by having a contact with the temperature or by the air. Then it going to the circuit with the pull-up resistor here and going to the Arduino. Then the data will be gathered here in the computer. Then after the measurement at 2 points, it will have a temperature difference reading, and it will have the basis for the quadrant or the measurement for the water pump to have a lesser flow. Now I'll show you how it works. You just pull up the main switch from the power, turn on, then the water flow from here to there. Then there's the reading. It's dropping by 33.25 to 33.19. So the water is very cold. As of now, we only have the temperature sensor at the starting point. But in the reality, when the steam generator is open, the steam will pass through here the pipe, then go with this temperature sensor. So there will be an increase in temperature between the first point and the second point because of the steam that is superheated.
Morning guys. So here is a servo motor. We're going to use this for our experiment to control the flow. As you can see here, it's already moving. Our plan is that the temperature difference of the system will cause the servo motor to move at a certain angle, which causes a change in flow depending on the needed of system. This servo motor will control the quadrant. Now you may ask, what is a quadrant? Quadrant is a special types of transistors which combines a diac and a triac, meaning you only need to use one. Instead of using a triac and a diac, you only need to use a quadrant. Here's the data that we gathered when we did our first experiment. The first experiment was using only water. Then this time, we haven't decreased the flow yet. So as you can see, the flow is fixed and the temperature is also fixed. So that was our first trial.